Hey, Chris here. We're going to do a little 3, 4, and 5 for Unit 3 review, and we're just going to start off with this reminding about 4 over 1 to the negative 1. The negative means we can flip the base. We don't have to, but we can if we want to, especially if we're asking for a question with the base being positive. So when we do flip the base, that becomes 1 over 4. And the only thing changes is now that's a positive 1, and we're kind of lazy in math. We don't write the positive. But the sign of the base doesn't change. So for example, if I had this one with a negative sign here, negative 1 over 4, they would become 4 over 1 to the positive 1. But that negative sign is still inside the fraction, so I'm going to stick it right there. It doesn't matter if it's on the top or the bottom or the outside, it's still a negative, okay? So the flipping will change the sign of the exponent, but it doesn't do anything for the base. 4 over 1 to the negative 2, we knew then became 1 over 4 to the positive 2. And if we wanted to evaluate, that's simplified. If we wanted to, or simplified with a positive exponent, if we wanted to evaluate, that's the same thing as 1 squared over 4 squared, which would be 1 over 16. I'll put a little box around it. We could have thought that as well. Could have been, I'll do it over here, it could have been 1/4 times 1/4 equals 1 over 16, the exact same thing, right? Okay, if it's 1 over 4 to the negative 2, same idea, becomes 4 over 1 to the positive 2, becomes 4 squared over 1 squared, or we could just say 16, or we could say 16 over 1, it doesn't really matter. Okay? All right, let's move on. 8 to the 2/3, that's getting a little trickier. I kind of like to think about saying, okay, that's really like 8 squared, but then there's this 3 on the bottom, and I'd like to get rid of the 3 first because it kind of is the worst part of it. So what I'm going to do is I'm going to say it's still going to be an 8 in there. That's the base. But now this 3 becomes the cube root. So it's a cube root of 8, and the squared is just waiting there to be used afterwards. Okay, so it's a cube root of 8 squared. The cube root of 8 means what number multiplied by itself 3 times is 8. We can use Desmos calculator if you like. And we're looking for the cube roots, the nth root. That lets me put the little 3 here of 8, and it gives me the answer of 2. So coming back here, the cube root of 8 is 2. I'm going to leave it in brackets, and it's still squared. And then we know 2 squared is equal to 4. I can do in Desmos get the final answer too. I'm still going to make you go through the steps, but I could do 8 to the power of bracket. I'm going to use brackets on this one, 2. I don't know if I had 2, but I'm going to do it anyway. 8 to the power of 2/3. The final answer is 4. So I can check my work. The final answer is still 4. Same idea here, 4 to the 3 squared. I still know that the 3 is going to sit there, but then I'm going to have the square root of 4, because that 2 belongs inside there. That's the root part. Oftentimes we leave the 2 out for square root because it's so common, but we're going to put it in here this time. So now we've got the square root of 4 is 2. We still have to the power of 3. And now we're left with 2 cubed is 8. 2 times 2 times 2 is 8. Similar idea here. 9 to the 3/2 will become the square root of 9. And the 3 is just waiting there. So the square root of 9 we know is 3. And 3 cubed is 27. Okay, so I do encourage you not to just watch this, but to try it yourself. Do the exact same questions yourself to see how things go. Okay, same idea here now is I've got the negative and a fractional indice or exponent. So let's get rid of the negative first because it kind of bothers me the most. And I'm going to start with, now that becomes 9 over 4 to the positive 3/2. Some people try to flip the 3/2 to 2/3. It's not. We're just flipping the base, which is this 4/9 becomes 9/4. That took care of the negative sign, and now it's a positive 3/2. Now we're going to get rid of that denominator part, that 2, and it's going to hit the top and the bottom of the fraction. So I got the square root. I could do it as the, I'm going to write it here, square root of 9/4, but that looks a little bit confusing. So I'm going to break it into the top and the bottom. The square root of 9 over the square root of 4. And the 3 is still waiting there, so I'm going to leave him there. And I could stick the little 2 in here. So now I've got the square root of 9 is 3. The square root of 4 is 2. I still have to the power of 3. Sorry, I left some stuff at the bottom here. So now I've got, I like to write it out. Some people don't. 3 cubed over 2 cubed equals 3 cubed is 27 over 2 cubed is 8. A lot of people are going to write 6 there because they start thinking 2 times 3, but it's 2 cubed, which means 2 times 2 times 2, which is 8. Use your calculator if you like to double check. Okay. We also look sometimes at breaking this 8 into something else. So we could talk about this 8 as being 2 cubed is the same thing as 8, because we just saw that on the last one, to the power of 1/3. So there's another way of breaking things down here, and then we could say, okay, wait a minute, now you get that power to a power thing. That's the same thing as 2 to the 3 times 1/3. Right, power to a power, we multiply the exponents, equals 2 to the 3/3, or just 2 to the 1. So there's another way of doing the same thing, 8 to the 1/3. We could do it as cube root of 8. So I'm going to write down here at the bottom here, oops. Or we could have said it's the cube root of 8 to the power of 1, ends up being 2 to the 1, or just 2. So 2 different ways of doing the same thing. Okay, getting there. Next one up, I have 3 to the x equals 3 cubed, find x. Well, all we're going to use is the advantage that the bases are the same, so then the powers must be the same as well. Okay, if the bases are exactly the same, then the powers must equal. So we're just going to use that and then say, okay, well then x has to equal 3. Okay, if 3 to the x equals 3 to the 3, well then this number here must be the same as this number here, x equals 3. Same one on the next one, however, we're going to have to break it down a little bit and say I don't have a 2 on the right hand side. So I could take advantage of saying, well, I know that 8 is the same thing as 2 cubed. So I could say 2 to the x equals 2 cubed. Now I can do it just like the previous question. If the bases are the same, then those exponents must be the same, and I could be left with x equals 3. I could double check my work. Check. 2 to the power of 3 equals 8. Yep. So if x is 3, that works. 2 to the cubed is 8. Okay. We could also do something with graphing. We could graph, if we wanted to say 2 to the x equals 8, find x, we could graph y equals 2 to the x, and we could graph y equals 8, and where they intersect, that's going to be the x value I'm looking for to find what makes this true, and I'm going to show you that on a graph now. So I'm in Desmos graphing calculator. I'm going to graph y equals 2. I'm going to use the little hat button to get my exponent to the x. Okay, and I'm going to hit enter. I'm going to hit y equals 8. Enter. So if I say y equals 2 to the x and y equals 8, then if I zoom out a little bit, where they cross, I'm going to click on the button here. Where they cross, that happens when x equals 3. Obviously the second number is going to be 8 because y equals 8, but also in the graph y equals 2 to the x, the y is equal to 8. So if y equals 2 to the x and y equals 8, well, the only time that's both true is when x is equal to 3, and I was trying to find the value of x, so that means x is equal to 3. So I come back to my Jamboard here. The only time that happens is here, which was 3. So x equals. So another way of doing the same question, it's nice on here because the numbers worked out nicely, but the graphing could help me if the numbers don't work out nicely. And there's an example of that graph. You can type that in. I think comes to the same spot. So what if I tried this y equals 2 to the x and y equals 9? Y equals 2 to the x, and I'm going to graph y equals 9. Where they intersect, which is up in here, I'm going to show it on the graph in a second, is going to tell me x equals something. So 2 to the something equals 9. So let's try it. Y equals 2 to the x, and y equals, instead of 8, we're going to say y equals 9. So I'm going to click on where they intersect, and it happens at, oh, it's not quite as nice this time, 3.17. Okay, so the x value is 3.17. Let me come back here, whoops. X equals 3.17. We could check. Here's my check at the top here. 2 to the 3.17, does that equal 9? Well, let me use my calculator. 2 to the 3.17, that's close enough to 9, 9.000, so that works really well. Okay, same idea here. This one's getting really tricky, and you don't need to know this one necessarily, but those who want to expand on this one, this is getting tricky. Again, I want the bases to be the same, so I'm going to try and change 16 into a 2. So I've got, my question is 2 to the 2x equals 2 to the what? Well, 2 to the 4th is equal to 16. Now my bases are the same, so that means the exponents must be equal. And I'm left with 2x equals 4. I want x on its own. We know from solving equations we divide both sides by 2, and we're left with x equals 2. Okay, I force the bases to be the same. In this case, 2x equals 4 because the exponents had to be the same, or x equals 2. Or again, I could graph it. Y equals 2 to the 2x and y equals 16. So let's do that. Y equals 2 to the 2x. Oops, got to get that 1x out of there. 2 to the 2x, get out of there. And y equals 16. And I got to find where they cross. Boom, right there when x equals 2, y is equal to 16. Okay. So when x equals 2, 2 to the 4 is equal to 16, and when x equals 2, we know y is always equal to 16 for the second equation, so we just verified it. Alrighty. I would try this yourself first, and then see how I go. So pause it, and see if you can do that one first before I do it myself. Okay, hopefully you've paused and tried it. So now I've got 3 to the 2x. I'm going to try and take the same advantage and say that's the same as 3 to the what is 27? 3 cubed is 27. The bases are the same now. Then I know that 2x equals 3 because the powers must be equal. Since the bases are the same. 2x equals 3, but I want x on its own. So I'm going to divide both sides by 2. And I'm left with x equals 3 halves or 1 1/2, whatever way you want to do it. So 3 halves, I think, is a good one. Okay. Or I could graph this same thing. Y equals 3 to the 2x. Y equals 3 to the 2x. And y equals 27. I got to find where they cross. It's way up here. Gives me an answer of 1 1/2. Is that the same thing as 3 halves? Yeah. Y equals 1.5 from graph. So both methods work. Okay, moving on to solving percentages, and just a quick little review of means times. So if you see 50% of 500, that means times or multiply. And we know 50% is the same thing as 50%, if you're like your French, per 100. Means times 500. Okay. Now some people may not write 50 out of 100. They may write this as a decimal, so I'm going to show you that first. 50 divided by 100 is 0.5. So some people are going to write 0.5 or 0.50. There's your 50 out of 100 times 500 equals, so I'm going to do that, times 500 gives me 250, which makes sense. It's half of 500, right? But it's nice to do these questions where you know the answer, half of 500 or 50% of 500 is 250, and then try it on another one where you're maybe not quite so sure. 30% of 600 may not come out right away, but we can go ahead and use this method we know it worked, and then try it on one that's we're not quite so sure. Okay, so same idea here. We're going to have 30% times 600 equals, use my calculator, I'm going to just type over top of this, 30, and it was times 600, gives me 180. Okay, so that's just a percentage of something. Now we're going to look at percentage increase and percentage decrease. If I want to increase, I want 10% increase on 450, I can do this two ways. I can do it first way, would say, okay, I want 10% of 450, which is kind of the long way. 10% of 450, that'll be the increase. 450 would equal 10 out of 100 times 450. I won't show the calculator on this one. Equals $45. So the new value would be the original value, the 450 plus the increase of 45, and that gives me 495. I'll put 2 decimals because it's money. The second way of doing it is this one, which I've typed in here. I take the original and I add 10%. So the original is 100%, like I want all of it, plus another 10%. It says I want 110%, and people talk about it, give me 110%. That's what it means, 10% more than the original. So if I want 110% of 450, that'd be 110% as a decimal is 1.10. I'll show that on my calculator. 110 divided by 100 is 1.1 or 1.10. Okay, times 450 gives me the same thing. So I get to do it in one shot rather than piecing it together, find the increase and then add it. I do it all in once. I say I want 10% more, so it's going to be 110% of. The same idea here, if I wanted a decrease, I take the original minus 10%. So 100% minus 10% is, I only want 90% of the 450. So 90% of the 450 becomes 90% is as a decimal, so 90 per 100 as a decimal, 0.9 or 0.90. I like that for the 90. Of means times 450 equals 405. Now I could have said take the 10% of 450, like in the last one, knew that was $45, and then said, okay, take the original 450 minus 45, I still get to 405. Totally works too. This just lets you do it in one step. Okay, so same idea. However, with a smaller increase, like 1.5%, people get a little confused with the numbers and they start putting 115% instead of 101.5%. So think of it this way, 100% plus 1.5% equals 101.5%. Okay, so if we want 101.5% of 600, that equals 101.5 as a decimal, 101.5 per 100 or percent is 1.015. So just watch out for that. 1.015 times 600. And we're going to see this when we're doing some money stuff of earning interest. So 1.015 times 600, it gives me $609. Okay, so that's a small increase. Let's try the next one. Gets a little trickier here. And again, this review I'm doing, that'll take half an hour, is not replacing all of Unit 3, 4, and 5 content stuff. It's just a review of it, so you should have looked through the content first or afterwards. So we've got something in grade 11 math you should have learned about growth and decay. And the formula is an exponential formula, y equals ab to the x, where a is the initial amount, b is the growth or decay factor, and x is the time period. Okay, and that's going to evolve into some compound interest stuff later on. So the growth factor says, what if we want to double every 20 minutes? Well, then the growth factor, I've kind of separated this here to a growth versus decay. The growth factor would be 2 because we're doubling. Okay, and I could think of it this way: as doubling is the same thing as 200% of the original, and 200% as a decimal is just 2. 200% is just equal to 2. So that's one way of doing it. Decay is a little different because people get confused with that. We're subtracting it, so it's like you took the original for doubling. We took 100% the original, plus we added another 100% because we were doubling, right? The same idea here is, what if I wanted to decrease by 1.5%? Well, I do the same thing as the original minus 1.5% ends up being 98.5%, or as a decimal 0.985. So we're going to use that b here as our growth or decay factor. So it could be 2 if we're doubling, could be 0.985. It's going to be less than 1 if we are decaying, if we're getting smaller. So we'll try one like this. Loyola school population is growing at a rate of, I'm making this up, 2% per year. If the current population is 560 students, how many students will there be in 3 years? And I can use this p equals ab to the x, where p is the population, a is the initial amount, In this case, it's 560. B is my growth factor. So we're going to increase by 2%. So I took the original 100% and we're increasing by 2%. So that equals 102%, or as a decimal, 1.02. Okay? And X is just the number of years. I can do this in a spreadsheet. I'm going to show you that in a second. But we can also use just the formula P if I wanted to find for 3 years. In this case, so X is the number of years, but if we wanted specifically for 3 years, P would equal AB to the X, or P is equal to 560 times B, which we said is 1.02 to the power of 3 if it was 3 years. So let's try that in our calculator. 560 times, I'm going to use brackets here just to be sure, 1.02, close the brackets, to the power of, so let's shift 6, get that hat symbol, of 3 for 3 years, 594.27. I'm not going to have 0.27 of a student, so I'm just going to go ahead and round it to 520, 594, I forgot, 594. 594. Okay, we could graph that as well though. Okay, I'm going to start here with X, and I'm going to say from 0 years, 1 year, 2 year, 3, 4, 5, 6, and then we know that our equation is Y equals 560, the original, times 1.02 to the X. So this better work out to be 560 when I actually do the calculation. Let's try it. Equals 560 times, I'm going to use brackets, 1.02, close the brackets, to the power of whatever the X value is. And think of it, 1.02 to the power of 0 is just 1, so this ended up being 560 times 1, so it's still going to be 560. And then I can zoom this down. Now this is a slow growth. It's still exponential, but it's growing because we get to earn interest on the interest, if you're thinking money, that we're increasing as we go through. So I can graph this, insert chart. And it's hard to see. It almost looks linear but it is actually growing slowly, very slowly. Okay. The other thing I'm going to note is the Y-intercept. If I'm looking at a graph, this vertical line here when X is 0 is the Y-axis, and the horizontal line is the X-axis. So where does the graph cross the Y-axis? What happens when X equals 0? So I'm going to highlight that right here in green. The Y-intercept, Y-intercept is going to be 560. When X is 0, what's the Y value? That's the Y-intercept. Okay. So let's go and try this one. If you invest 600 at an interest rate of 4% per annum compounded annually, what's the total of the investment after 10 years, 20 years, and 40 years? This gets a little different now because we have to break this down to watch out our annual compounding versus our if it was monthly or whatever. This one's annually, so it's not going to be a problem. Later on, we're going to do ones where it's monthly or biannually or whatever else, and it'll become a little problem. So this one will be a little bit easier. The principal is 600. That's what we're starting with. The P is. So I'm going to reverse this one. I'm going to say A equals PB to the X instead, where A is the final amount, and P is what we call the principal. That's what we're going to use for, rather than the final population or the initial amount. P is going to be the principal, which is how much we originally put in. So B is going to be, and we're going to change this to an I and an N later on, but for this simple one, is going to be 100% plus 4% equals 104%, or 1.04, and X is the number of years. We're going to be changing this into an I and an N later on because we're going to allow for compounding, not just yearly. Okay, so if I can then say A equals, the final amount is equal to P bracket, or I don't need the bracket, P B to the X. I like creating the formula first. A equals the initial amount was $600. 600 times b is 1.04 to the, how many years we want to do? After 10 years, we could put in a 10. So for 10 years, we can do a 10, so that's 600 times 1.04. I can just use this one, 600 times 1.04 to the 10 gives us 88815. I'm going to round to 2 decimal places, 88815. Okay. If I want to do for 20 years, I change that to a 20. 40 years, I change that to a 40. Or I can graph it. So we'll look at the graph. And I just went ahead and did it. So it's x can go from 0 to whatever. Y is going to be 600 times 1.04 to the x. So there's 10 was that 88815, the one we just did. 20 we can pull from the spreadsheet here. 40 we can pull from the spreadsheet here. I'm going to note the y-intercept is 600 because again that's the initial value. When x is 0, where is the line crossing the y-axis, which is this vertical line? It happens at, it's hard to see on the graph. I go back to the spreadsheet, I can see it's 600. So now we're going to look at investments really specifically, slightly different. It's going to say A equals P 1 plus I to the N. Same idea. Okay, it looks really like PB to the X, but I'm breaking that B down to saying take the initial, the 100% plus the whatever interest rate we're going to do, and we can worry about it for as a decimal. And we're going to worry about that interest rate as being divided by the number of compounding periods per year. Because if I'm going to compound yearly, that's easy. But if I'm going to compound monthly, I've got to do these calculations on calculations. And the interest rate is typically given as interest rate per year, but then we got to break it down into compounding monthly. So I need to say, okay, it's only a 1/12 of the yearly interest rate because I'm going to do it every month. And the N is the number of years times the number of compounding periods per year. So if I want to say it's 2 years, but we're compounding 12 times a month, 12 times a year, and it would be 24. We'll work through that anyway. So this is something we're really going to go back to, and we're going to try one of those now. If you invest 600 at an interest rate of 4% per annum compounded monthly, so now the interest rate can't be 4%, it's got to be 0.04 divided by 12 because we need to say we're only getting a piece of it each month. So let's go ahead and work through the same similar one, but we're going to compound monthly instead of yearly. So P is the principal, was 600. I now is going to be the interest rate as a decimal, 0.04 divided by the number of compounding periods here is 12. So that's a horrible decimal, 0.00333333. Okay? I'm going to hold most of that in my calculator in a minute. N is going to be, how many times we're going to do this? In 10 years, there's actually 120 months. There's 10 years times there's 12 months in a year, so we're going to actually do 120 of these calculations, and A is going to be how much do we have afterwards. So for this one, A equals P, sorry, I've already got the P, so we'll go ahead and put it in there, 600. And now I'm going to say 1, the original, that 100% plus this little piece of interest, 0.0300, sorry, 0.03333 to the power of N, in this case is 120. Okay, so that's my 10-year one. So A equals, let's go ahead and do it on our calculator. So 600 times 1 plus 0.0033, whole bunch of these. Okay, or I could have done 1 plus brackets 0.04 divided by 12 to get a little more accurate if I wanted to. And again, it was for now 10 years, but that's really 120 months, so I'm going to do 120. So my final answer should be, whoops, that's not right. That should be to the power of, pardon me. I got too many brackets in here. There we go. To the power of 120. 894.50. 894.50. Okay, so that was 10 years, but we're compounding monthly. Everything else was the same. The previous one was 10 years, but we're compounding yearly, 888.15 versus 894.50. So if you can compound more regularly, you get to earn interest on off that interest, you get to go a little bit faster. Okay, and that is the end.